Our next topic is proportions. To begin, we're going to review what we know about ratios. Now ratios, we have three forms, but this week we're really going to be focusing solely on the fraction form. Let's read through the first example here. Bubbles the clown has a bag filled with 15 black marbles, 4 blue marbles, 10 violet marbles, 8 red marbles, 16 yellow marbles, 19 white marbles, and 7 brown marbles. Answer the following questions with this information. We're going to first find the ratio of red marbles to violet marbles. Let's write this in words. We're going to be talking about red marbles to yellow marbles. That means red is our numerator and yellow marbles are going to be our denominator. I think it's very helpful to always write our ratios out in words and then translate to numbers. So here, if we're looking at our red marbles, we're going to be talking about 8 red marbles to 16 yellow marbles. Now, of course, when we have a fraction, we always need to remember to reduce. So our simplified ratio is 1/2. For part B, we're going to find the ratio of blue marbles to all the marbles. Well, if we're going to find all the marbles, we're going to have to add up all the individual marbles to see the total number of marbles that we have. So we're going to take 15 black plus 4 blue plus 10 violet plus 8 red plus 16 yellow plus 19 white, and lastly 7 brown. Now I will save you the trouble of your calculator and tell you that there are 79 total marbles. So again, we're going to find the ratio of the blue marbles to all the marbles. So I'm going to write this out in words. Blue to all, which means that we have 8 blue marbles over 79 total. This is the fully simplified fraction because there's not a common divisor between 8 and 79. Moving on to the level 2, we're going to be talking about unit rates. Here we have a car drives 192 miles on 6 gallons. How many miles will the car drive on 1 gallon? Whenever we're finding something where the denominator is going to be 1, or the unit rate, here we have 192 miles are driven when we have 6 gallons in the car. Now we want to know how many miles it will take the car to drive on 1 gallon. Again, this is called a unit rate. So notice the gallons match up with gallons and the miles match up with miles. Our numerators are the same and denominators are the same units. When we cross multiply and divide, we get that we can go 32 miles on 1 gallon. And that is our answer. That's our unit rate. Let's try another example just to reiterate that we know how to do this. If 4 pounds of shrimp cost $36, how much will 1 pound of shrimp cost? We have 4 pounds of shrimp costing $36. We want to know how much 1 pound of shrimp will cost. That's our X dollars. Again, notice pounds match with pounds in the numerator and dollars in the denominator. Now if we cross multiply and divide again, 36 times 1 is 36 divided by 4 leaves us with $9 per pound of shrimp. As we move on to the level 3, we're going to be using the same type of proportions, but now we're not going to have one of the numerator denominator being a value of 1. If 20 people fit into 5 cars, how many people can fit into 15 cars? We're again going to set up a proportion. So what I'm going to do is I'm going to write my little ratio over here to keep in mind how I want to do this, how I want to set up my proportion. So I'm going to have people as the numerator and the number of cars as the denominator. So if I have 20 people, I'm going to abbreviate that with PPL, are in 5 cars, we want to know how many people fit into 15 cars. Okay, so my numerator on my right side is going to be x. So again, we have 20 people here in our numerator. We have x people in our numerator on the right side, and our cars match with cars. So, looking at this, I'm going to cross multiply and divide, and I get x equal to 60, and we're going to talk about people. Hopefully I can fit this on the edge. Yes, I can. So 60 people can fit into 15 cars. Let's take a look at number 5. Have you ever had trouble with a computer lately? A recent study indicated that 2 out of 5 families run into trouble with a computer in the course of a year. If 3,000 families were surveyed, how many families would have run into trouble with the computer? So again, we're going to set it up so that we're going to have our ratio of words on the left side. I'm going to call this the families with trouble over total number of families. Okay, this seems a little confusing, but I think once we put the numbers in, it will make more sense. So if we have 2 families out of 5 total families, then this is equal to x number of families that have trouble over the total of 3,000 families that were surveyed. Again, when we cross multiply and divide, 2 times 3,000 divided by 5, we get that x equals 1,200 families. And I'm going to have to abbreviate this because there's not enough room. Okay, the last problem we're going to take a look at is a level 4, which is a challenge problem. This is going to use both proportions and conversions. Let's take a look at it. A rhinoceros beetle weighs 30 grams and can carry 850 times its body weight. That is 25,500 grams. If a person could carry proportionally as much as the rhinoceros beetle, how much could a 60 kilogram student carry? So that's somebody about your size. Let's see. 1 kilogram is equal to 1,000 grams. So let's do our conversion first. If we have a person who is 60 kilograms, let's see how many grams he weighs. If we recall our conversions from the beginning of the school year, we're going to set up this little table so that we can properly convert from kilograms to grams. And I put my kilograms on the bottom in my conversion using my conversion factor so that they would properly cancel out, as we see here. So then when I multiply across 60 times 1,000, I'm going to get 60,000 grams. So that's the weight of the person. What we're going to be talking about here is let's set up a proportion of the weight. I think I moved something. Okay. The weight of either the beetle or the person over how much they can carry. This is going to be our proportion. Let's see. If the beetle is 30 grams and he can carry 25,500 grams and the person weighs 60,000 grams, we're going to see how much this student can carry. If we notice here, the left side of our proportion, this is talking about the beetle. And, let me change that color so you can see this visually. The right side of the equation is talking about a student. If we cross multiply and divide, we get the student can carry 51 million grams. Now that is a lot. We don't really have an accurate reading of that, and as we look back at the question, it doesn't ask us for what measurement it wants it in. But in case we wanted to, let's also do the conversion of 51, I'm going to try and write really small, million grams. Let's convert it to kilograms and see that as well. We have 1,000 grams here in 1 kilogram. Again, the grams are going to cancel out, so we're going to be left with kilograms. And when we divide 51 million divided by 1,000, we're left with 51,000 kilograms. So we did some extra work there, but extra practice never hurt anybody.